These are the notes on the mole and molar mass. You will want to have the notes available to fill out with me, and then a periodic table and a calculator. Holy moly, computers can count at a rate of over 800 million counts per second. At this rate, it would take a computer over 25 million years to count to a mole, which is 6.022 times 10 to the 23rd. A mole of marshmallows would cover the planet Earth 12 miles high, and a mole of hockey pucks would be equal to the mass of the moon. Hopefully you watched that intro video on the mole to get a little bit of background on it. The mole is our counting unit in chemistry. It is a huge number and it's used to count tiny things. So when we're talking about atoms or molecules or particles, it's easier for us to quantify or count in chemistry by a mole than by these individual pieces. Kind of like 1 dozen bagels is 12 individual bagels. It's like that, but for a much larger number. And so the definition of a mole is that 1 mole is 6.022 times 10 to the 23rd atoms, or of something, whether it's individual atoms or if it's a molecule or a particle. This value is a mole, kind of like a dozen is 12. These three terms do mean different things. We're going to kind of just consistently use particles because when we abbreviate molecules to MC, it can get a little bit confusing with mole, which starts with an M. And so we are going to use these conversion factors, like 1 mole over 6.022 times 10 to the 23rd, because those two things are equal. If we write them as a fraction over one another, that has a value of 1. So it allows us to switch from a unit of particles to a unit of moles if that's something we need to do. If we flip that fraction, so we have particles on the top and moles on the bottom, then that will switch, allow us to switch from moles to particles, so changing units. We don't have a scale to measure moles. We don't have a scale to measure molecules. Part of that is because every atom and every element has a different mass. So relating this to something we can quantify or measure in a lab, we are going to use molar mass. And what was found is that 1 mole, that's 6.022 times 10 to the 23rd molecules or particles, is equal to molar mass. And that's information we can get from our periodic table in grams. And so we can, again, with those conversion factors, write this as a fraction. 1 mole over molar mass equals 1. Molar mass over 1 mole also equals 1. So those are equivalent values, meaning it can help us switch between units. All right, and we're going to look at conversions in our next set of notes. For now, we're just going to kind of look at the mole and how can we compare 1 mole versus particles versus grams, a mass measurement of these, and we're going to look at molar mass. So the mole, if we have solid carbon, carbon is an element that will exist on its own. It'll bond with other carbons, but that solid carbon has a chemical formula of just C, 1 carbon by itself, and 1 mole of carbon is going to be 6.022 times 10 to the 23rd particles of carbon, so individual carbons. That's our definition of a mole. But that molar mass, 1 mole is also equal to 12 grams. When we look at our periodic table, carbon has this 12.01 on the bottom, that atomic mass, which is going to be how we can figure that out. And so that says that 1 mole of carbon, that 6.022 times 10 to the 23rd particles, is going to have a mass of 12 grams for carbon. And everything has a different mass, so we'll see on here, depending on what our element is, we can grab that mass to find what would be the mass of 1 mole. Water vapor down at the bottom. Water is made up of 2 hydrogens and 1 oxygen. And those are in molecules or particles. 1 mole is going to be 6.022 times 10 to the 23rd H2O particles. The molar mass, though, now because water vapor is made up of hydrogens and oxygens, to find our molar mass, we're going to have to take into account that we have 2 hydrogens. And so we go 2 times, well, the molar mass of hydrogen is 1.008. We're going to round that to a 1. Plus, we have 1 oxygen. Oxygen has a molar mass of 16. And so to find what would be the molar mass for those water particles, we would get that 18 grams. So if something exists as just a single element, we just use whatever value is on the periodic table. If something is existing in a compound, whether it's ionic or covalent, we just need to take into account how many we have of each in that molecule. All right, let's try 2 on our own. 2 more. Nitrogen gas. Nitrogen is one of those special elements that we marked on our periodic table at the beginning of the year as being diatomic. So the diatomic elements are hydrogen, and you can see in the key down on the bottom right, the diatomic elements have that kind of line shading through it. So hydrogen is diatomic, nitrogen, oxygen, fluorine, bromine, and iodine are all diatomic, meaning that if we have something like nitrogen gas, it's going to always exist in as 2 nitrogen together. And that's true for all of these. They only exist in pairs as a compound or attached to its twin. And so because it says on here, nitrogen gas, it's going to be N2, meaning 1 mole is going to be 6.022 times 10 to the 23rd of these particles. But when we're looking at what is the mass of 1 mole, we're going to have to go 2 times. The mass of nitrogen is 14. If I look on my periodic table there. And so 2 times 14 is 18. So 1 mole of nitrogen is also going to have a mass of 18 grams. Carbon dioxide gas, 1 mole is 6.022 times 10 to the 23rd particles. That's Avogadro's number. It never changes. It's always that many particles in 1 mole. But because those particles can have different sizes, 1 mole equals molar mass. When we look at this, we've got 1 carbon, so 1 times, we go to our periodic table and find what is the mass of carbon. We're going to round to the nearest whole number, 12 plus 2 oxygens. Oxygen is 16. And we're going to add those together. So we get 12 plus 32, which is 44 grams in 1 mole of carbon dioxide. Okay. So we've practiced finding molar mass. These are a couple more, just kind of walking through that steps of finding molar mass. This one's not too tricky, but they do get a little trickier as we go. So potassium fluoride, in order to calculate that molar mass, and remembering that 1 mole equals the molar mass in grams. 1 mole, we're going to determine the number of each atom in the formula. So if we look at potassium fluoride, this is K1F1. So we have 1 of each. We're going to find the mass of the element on the periodic table and use the rounded mass. So I have 1 potassium, and that has a mass of, here we are, 39.1. So I'm going to round that to 39. Plus, I have 1 fluorine, and I'm going to find the mass, 1 fluorine. Fluorine has a mass of 19. And I'm going to multiply those. 1 times 39 is 39, plus 1 times 19 is 19, and add those up. So this is equal to 58, and that's 58 grams are in 1 mole of potassium fluoride. So that has a molar mass of 58 grams per mole. This next one, magnesium chloride. Mg, we have 1 magnesium, so 1 times Go back to your periodic table or have another one open. Magnesium is 24.31 on the periodic table, so I'm going to just say plus is 24, plus my chlorine. I have 2 chlorines. Chlorine is 35.45 on my periodic table, so that's going to round to 35. 1 times 24 is 24, plus 2 times 35, 70. So we're going to add those together. We get a total of 94 grams per mole is the molar mass of magnesium chloride. Go ahead and pause the video, try this one on your own, and then come back to check your answer. All right, so we had 3 calciums and 2 nitrogens, so we got 148 grams per mole is the molar mass of calcium nitride. We have one left. This one's a little trickier because we have a polyatomic and we have multiple of those. So when we're looking at this 3 means that if I have Al, NO3, 3, that means I have 3 NO3s that are all in that compound. So when we're counting how many of each do we have, I'm only going to have 1 aluminum. When I look at how many nitrogens do I have, I'm going to have 1, 2, 3 nitrogens. And I can also get that by saying, okay, well, I have 1 nitrogen on the inside, a 3 on the outside. So if I go 1 times 3, that's going to be 3 nitrogens total. For my oxygens, because there are 3 oxygens in each NO3 grouping in each nitrate, when I look at how many I have for those oxygens, I have 3 plus 3 plus 3. So that's going to be a total of 9 oxygens in that compound. We can also get that by doing the 3 on the NO3 times the 3 outside is kind of the shorthand way that we can do this, so we don't have to write out this long version to see each of those. And so making sure you count the number correctly will help for us to get the correct molar mass. Now I'm able to go through and say, okay, well, aluminum has a mass, and again, I'm going to my periodic table. Over here, aluminum has a mass of 26.98. That's going to round to the nearest whole, so that's 27. Nitrogen is going to have a mass of, going to my periodic table, 14. And each oxygen has a mass of 16. And I can now multiply these and add them up. So this 1 times 27 is 27. 3 times 14 is 42. 9 times 16 is 144. And to find the mass of that whole molecule, I'm going to add 27 plus 42 plus 144. And so the molar mass of aluminum nitrate is 213 grams per mole. All right. Take a look at our rubric. There is a worksheet posted and a check-in. Check in with your teacher if you need any further help, and good luck.